Hey everyone. So here in the next couple of days, we are going to be working on adding and subtracting rational expressions, which actually is slightly more challenging than multiplying rational expressions, which I hope that you have found to be quite simple. So let's get started. As usual, I'm going to get you started with a numerical example. So 3/8 plus 9/8. This is a simple problem because we have a common denominator. So when you have a common denominator, you simply combine the numerators and you're done. So 3/8 plus 9/8 would be the same as 12/8, which is 1.5 or 3/2. But let's get to the good stuff. So what if I have this? I have x plus 4 over x minus 1 plus 2x plus 3 over x minus 1. So again, common denominator. And I'm really going to keep the same idea. I am going to combine my numerators. So x plus 2x is 3x, and 4 plus 3 is 7, which gives me 3x plus 7. And I keep my denominator, x minus 1. And I'm always checking equivalent expressions to give me equivalent graphs. And that's that. That is really all there is to combining when you have a common denominator. All right, works for addition and for subtraction. What about when we don't have a common denominator? Well, recall, if I'm adding 1/5 to 2/15, what I end up doing is I need to get a common denominator, and we like to get the common denominator to be 15, right? And the reason for that is because 15 is the least common multiple. At some point, maybe you decided that you could just multiply the two numerators and have the common denominator be 75. However, that would make you do a little bit more work than what you needed to. You know, having to do more simplifying. So what we try to do right here is we multiply the first fraction, 1/5, by 3 over 3, all right? And we know that because 15 has factors of 5 times 3, all right? So in the end, we add 3/15 to 2/15, and we get 5/15, which is equivalent, as you can see, all right? 5/15 or 1/3. That's the idea with numbers. When you're doing this with rational expressions, the same is true. Now, this first example that I'm going to do in this video, we are going to end up just multiplying our denominators. So I have one denominator of x plus 2 and one denominator is x minus 4. And I'm finding the difference between these two fractions. So all I'm going to do is I'm going to get a common denominator. To get this common denominator, by the way, this is the function. You can see the vertical asymptotes right there. The first fraction, I am going to multiply it by x minus 4 over x minus 4 because this denominator of x plus 2 would be missing a component of x minus 4. So I multiply x minus 4 over x minus 4, which is the same as multiplying 1. To the second fraction, I multiply x plus 2 over x plus 2 because that's going to lead me to have an equivalent denominator. All right. Now, what I'm going to do in this next step is I'm going to simplify the numerators of both of my fractions. So I get 4x minus 16 and 3x plus 6 in my numerators. Look at what I do with my denominators. I'm not going to multiply these out. So I'm actually just going to keep them as x plus 2 times x minus 4 on both of them. X plus 2 times x minus 4. All right. And I'm going to do that as long as I can. Unless the program asks you to enter the answers in expanded form, you can just leave these in factored form. All right. That's the neat thing about it. And at this point, I'm going to combine like terms because now I have a common denominator. Even if that common denominator is in factored form, you can still combine the numerators. All right. So 4x minus 3x is x, and negative 16 minus 6 is negative 22. And I'm just going to verify that I've got equivalent graphs, and it turns out that I do. So I am going to consider that my answer is correct. All right. So once again, what do we learn right there? Well, if you have a common denominator, just go ahead and combine your numerators. If you don't have a common denominator, find the common denominator. And you can do this by multiplying missing pieces to each denominator. In other words, a denominator of x plus 2 and a denominator of x minus 4. To be common, you would have to multiply those two denominators. In our next example, in the next video, we're going to find a common denominator without having to multiply the entire denominators together. So we're going to see that here in our final example that is coming up soon. All right. And equivalent expressions give me equivalent graphs. And that is solid gold. That helps me out a lot when I'm doing these problems.